Hi, good day everyone. This video is about inscribed angles and central angles. Again, I have here different set of problems and then let's try to answer this set of circles one by one by applying the concepts for inscribed angles and central angles. Right, so let's try to answer, by the way, let's try to explore the concept of central angles and inscribed angles. Alright, so again, according to our previous discussion, a central angle is an angle whose vertex is actually the center of the circle. So for example, we have this angle BAC. So obviously, the vertex of this angle BAC is the center of this circle. So automatically, the value or the measurement of that central angle is equal to its intercepted arc. Okay? So for this given figure, we have this angle. Alright, so we have this angle BAC. So automatically that is equal to its intercepted arc. So the endpoints of BAC, that is at point B and point C. So this arc or intercepted arc is equal to its center angle. So BC. Right? So for example, let's say we have this given angle. If angle BAC is equals to 90 degrees, automatically its intercepted arc is equals to 90 degrees. Okay? Next, for example, let's say we have this intercepted arc. If the value for intercepted arc, let's say that is 80 degrees, automatically the central angle is equals to 80 degrees. Right? So that is for central angle. Now, for inscribed angle, again, an inscribed angle has its vertex on the circle itself. That means all of the points, the endpoints, the vertex lies to our circle. So for example, we have this given angle. We have angle BCD for circle A, right? So we have this circle A and angle BCD, since the vertex lies at the center or the circle, by the way. So that is automatically considered as inscribed angle. Okay? This time, the value of the inscribed angle is actually half. Okay, half of its intercepted arc. Okay, so for this given problem, we have this intercepted arc for this inscribed angle BCD. Their endpoint, we have this point B and point D. That means we have this intercepted arc for this inscribed angle. Okay, so the value of this angle is actually half of its intercepted arc. So if we have this angle BD, we need to divide this by 2. Okay, for the value of BCD or the inscribed angle. Right, so for example, let's say we have this angle BCD, let's say that is equals to 100 degrees. Okay, automatically the value of its inscribed angle is half of that 100 degree. That is equals to 50 degrees. Okay, so that is the concept of inscribed angle. Next, let's reverse the process. For example, we have this angle BCD, which is actually the inscribed angle. Let's say this angle is equals to let's say 70 degrees. Okay, automatically the value of its inscribed or intercepted arc is times 2 of its value. So that is equals to 140 degrees. Right, so that is the concept of inscribed and central angles. Okay, so let's try to answer this set of problems. For example, number 1. Right, so let's say we have this given figure. We have this circle A with different set of values. Right, so we have this inscribed angle BCD with an arc of 140 degrees. Okay, so the value for arc BD is equals to 140 degrees. Let's solve for the value of angle C or angle BCD. So again, angle BCD is equals to the half of its intercepted arc. So the value of its intercepted arc, since that is 140, so let's divide this by 2. Automatically, the answer is 70 degrees. Okay, so according to our previous example, we have the same value. So this one is equals to 70 degrees. Right, so that is the simple concept of inscribed angle. Next, let's try to answer this given figure. Right, so same procedure since we have this inscribed angle. Our inscribed angle for this given problem, we have angle BCD and its intercepted arc is arc BD. Right, since the value of BCD is 80 degrees, okay, and that is equals to BD divided by 2. Right, so the measurement is half. If you want to do the algebra, um just eliminate the denominator, okay, by multiplying both sides of this equation to its LCD. So cancel out the denominator, therefore arc BD is equals to 160 degrees. Right? So that is one of our solution to solve this problem. Again, by using the concept, since this inscribed angle is 80 and its measurement is half of the intercepted arc, so just multiply the value of 80 by 2. Okay, so 80 times 2, that is simply equals to 160 degrees. So x is equals to 160 degrees. Okay, so that is our example. Next, let's try to answer this given problem. Alright, so for this given figure, we have this measurement. Okay, we have the central angle BAD. Okay, so again, angle BAD is an example of central angle. Automatically, the value of its intercepted arc is equal to the given central angle. So that is equals to arc BD. Okay, since we're asked to solve for the value of angle C, our first task is to solve for the value of arc BD. Okay, so that is our first task. Solve for the value of arc BD and then divide the value by 2 for the value of angle C. So that is our first task. Now, let's solve this one. Since according to our central angle, the value of BAD is 100 degrees, automatically that is equals to arc BD. Right? So, since we have this value, arc BD is 100 degrees, automatically we need to divide this value by 2, okay, for the value of angle C. Right? So, let's divide this 100 degrees by 2. So, therefore, the value of angle BCD is equals to arc BD all over 2. So, that is equals to 100 divided by 2. That is equals to 50 degrees. Right? Therefore, the value of angle C is equals to 50 degrees. Okay? So, that is the answer. Right? So, that is for this given problem. Next, let's try to answer this given figure. Alright, so this time, I think I have this 4 set, okay? 4 set of inscribed angle, okay? With their corresponding inscribed or intercepted arc. Now, let's try to solve for the value of different set of arcs. Okay, so number 1 is for solve for the values or the measurement of arc BC. Right, so let's solve for BC. Now, arc BC is again from point B up to point C. That is arc BC. Right, this time we have this inscribed angle for this given intercepted arc. That is angle A. Right, so that is from angle A. Since the value of angle A is 50, automatically we need to divide or multiply that value by 2, okay, for the value of arc BC. Since that is 50, automatically this part is equals to 100 degrees. Okay, therefore the answer for BC is equals to 100 degrees. Right, so that is our first answer. Next, let's try to answer. Let's say we have this arc, another arc. Let's say arc AD. Right, so this time is arc AD. Okay, so for arc AD again, that is from point A and point D. So we have this arc AD, and that intercepted arc is from angle A, C, D. Right, so that is from angle A, C, D. And according to our given figure, we have this 15 degrees for ACD. Automatically, we need to multiply this angle by 2. Therefore, this part is equals to 30 degrees. So, AD is equals to 30 degrees. Right, so I will remove this set of values. Right, so that is for question number 2. We have ACD. Okay, this time, let's try to solve for the value of angle B. Alright, so this time angle B. So where is angle B? So angle B is actually located here. Alright, so from this part, that is ABD. Angle B or angle ABD. So that is the same concept. Right, since we have this given angle, according to our previous example or problem, we have this 30 degrees for AD. AD is 30 degrees. Automatically divide this value by 2 for angle B. Since that is 30, divide by 2, angle B is 15 degrees. Right? Next, let's try to solve for the value of angle D. Alright, this time is angle D. So where is angle D? So we have this given angle. Again, okay, for this inscribed angle, we need to divide the measurement of arc BC, and according to our figure and given, BC is equals to 100 degrees. Okay, so that is equals to 100 degrees. That means we need to divide this 100 by 2. Therefore, angle D is equals to 50 degrees. Right? So we have this different set of values for this given figure. Okay, so we have this 130, 15, and 50 degrees. Right, so I will let's try to label all of the parts again. We have this two set of triangles. Okay, so let's solve this, or let's label all of the parts. So angle B is 15 degrees. So this part is 15 degrees. 15. Right, so let's try to solve for this part. Okay, if angle B is 15, angle A is 50, what will be the possible value of this part? What will be the possible angle? Right, so if we'd like to draw the figure formed, okay, that is actually a triangle. Right, so we have this given figure. I think that's the figure. So we have this 50 degrees for this part. We also have 15 degrees, and then our task is to solve for the remaining value, okay, or the remaining angle. Since the total measurement of a triangle, okay, that is equals to 180 degrees. Okay, that is the total interior angle of a triangle. Okay, alright, so that is, therefore, that is equals to 50 plus 15 plus the missing part, let's say that is x, is equals to 180 degrees. Right, so if you want to simplify and solve for x, that is 50 plus 15, that is 65 degrees plus x, and that is equals to 180 degrees. Right, so isolate the value of x, so subtract 65 both sides, therefore that is equals to x, and that is equal to 180 minus 65 degrees. Okay, so that is 65 degrees. Right, 65 degrees. Now, for the value of x again, subtract 180 or subtract 65 to 180. So 180 minus 65, that is equals to, that is 180 or 115, by the way. That is x as 115 degrees. Right, so that is the answer for this remaining angle. Okay, that is 115. Now, if you want to double check your answer, right, so again, for checking, if you want to double check, just add all of the values of your angle. Therefore, that is 115 plus 50 degrees. Okay, that is according to our figure, plus 50 plus 15. Okay, so 115 plus 50, that is 165. And 165 plus 15, that is equals to 180 degrees. Therefore, since this set of values are equal to 180 degrees, that means our answer is correct. So the answer is 115 degrees. Okay? Right, so let's try to solve another set of problem. Right, so I think this is our second to the last. Okay, so next. For example, we have this given figure. Okay, for circle C or for circle A, we have this given angle, angle BDC. Okay, an inscribed angle with a diameter. The value is 75 degrees. Okay, so again, angle BDC. So angle BDC is equals to 75 degrees. Right, so for example, you're asked to solve for the value of arc. Let's say arc BC. Right, so where is arc BC? That is from point B up to point C. So we have this arc BC. Since that is the inscribed or intercepted arc of this inscribed angle, we need to multiply the 75 by 2. Okay, that means we have 75 times 2, that is equals to 150 degrees. So BC is equals to 150 degrees. Alright, so that is according to the concept of inscribed angle. Now, for example, you are asked to solve for the value of angle C, another question, okay? So, for example, BC is, yes, that is equals to 150 degrees according to our solution. Now, what do you think? What will be the possible value of angle C? Okay? Now, I encourage you to pause this video and try to answer this one on your own. Alright, so let's try to answer. Now, since you're asked, or for example, you're asked to solve for the value of angle C, again, we have this BCD or angle C. since the value of BD is 150 degrees, alright, so this time we need to use the concept of diameter. Alright, so since we have this diameter, that is actually 9 segment BD, okay, that is our diameter, it actually divides our circle into two equal parts. That means it divides our circle into 180 degrees and another 180 degrees. Okay? Now, to solve for the value of angle C, we need to solve for the value of angle B first. Okay? We need to provide the value of angle B. Okay? This time, angle B is an example of inscribed angle. Okay? So, again, we have two methods actually. Number one is to solve for the value of B, and number two is to simply divide the intercepted arc of angle C. Right, so let's use our first concept by the way. So for angle C, since that is angle C, we have this intercepted arc that is from point D and point B. So we have this given intercepted arc. Since that is half of the circle, that is equals to 180 degrees. Divide this by 2, therefore angle C is equals to 90 degrees. Alright, so that is our first concept or method to answer this one. Next is by applying the concept of this another semicircle. Okay, since the value of this BC is 150, automatically we need to solve for the value of DC and divide DC by 2 to solve for the value of angle B. Right, so therefore if this BC is 150, so let's subtract 150 to 180, that is equals to 30 degrees. Right, since BC or DC is equals to 30 degrees, therefore angle B is equals to 15 degrees. Right, so let's divide this 30 by 2, that is equals to 15 degrees. Right, so according to our previous concept, the total measurement of the interior angle of a triangle is equals to 180. Therefore, let's say you have this x, therefore 75 plus 15 plus x, that is equal to 180 degrees. Right, so by simplifying this one, again, combine like term, 75 plus 15, that is equals to 90 degrees, plus x is equals to 180. Right, so isolate the value of x, so therefore that is x equals to 180 minus 90, therefore the value of x is simply equals to 90 degrees, and that is our answer. Okay, angle C is equals to 90 degrees. Right, next, our last problem, or by the way, we have this another problem, so sorry, so that is our next problem. So for this circle D, right, so we have this inscribed angle ABC. Right, so again, since the value of this circle or this intercepted arc is double of the value of this angle B, right, so let's equate this one. Therefore, since for example, we're asked to solve for the value of x, or for example, find x. Okay, therefore, arc AC, right, divided by 2 is equals to angle ABC. Right, since arc AC is 132 degrees, let's divide this one by 2 and then equate this value to the degree of ABC, and that is 8x plus 2. Right, so let's eliminate this denominator. By the way, if you want to simplify this, 132 divided by 2, that is equal to 66 degrees. I think that is 66. Right, so that is 132 divided by 2, 66, and that is equals to 8x plus 2. Right, so let's solve for the value of x again. Just isolate the value of x, so subtract to both sides, therefore 8x equals to 66 minus 2. Okay, and that is equals to 64 equals to 8x, divide both sides by 8. Right, therefore the value of x is 64 divided by 8, that is equals to 8. So that is the value of x. Now, if you want to double check your answer, again, simple checking, just plug in the value of 8 or x to our expression, since that is equals to 8x plus 2, therefore that is equals to 8 times 8 plus 2. Right, so 8 times 8 is 64 plus 2, that is equals to 66, which is actually the value of the half of the value of this intercepted arc. Okay, so the value of x is equals to, according to our solution, that is equals to 8. So our answer is 8. Okay, and then right, so this is our last problem. Okay, so I will crop this one. Right, so for our last problem, for example, we are asked to solve for the value of angle C. Right, so let's try to solve for the value of angle C. Again, since we have this given figure, the value of angle C is actually half of its corresponding intercepted arc. Right, so our first task is to solve for the value of arc BD, divide the value of arc BD by 2 to solve for the value of C. Okay, again, we have this given set of values. We have this first arc as 150 degrees. Right, so let's add this one to the second arc, that is 80 degrees. And then, let's add this missing part. Okay, this remaining part, that is, let's name this one as x. Okay, so plus x, so that is equals to 360 degrees. Okay, that is according to the concept of circle. Now, let's simplify this one. Let's solve for the value of x and then divide this by 2 to solve for the value of angle C. Okay, now, again, we have 150 plus 80. So 150 plus 80, that is equals to, I think, 230. So 230 degrees plus x equals to 360 degrees. So I isolate the value of x, therefore subtract both sides by 230. So that is x equals to 360 minus 230. Therefore, the value of x is equals to 130 degrees. Right? So since the value of x is 130, so let's label this one as 130 degrees. Therefore, if you want to solve for the value of angle C, divide this 130 degree, okay, by 2. Okay, since that is an inscribed angle. Okay, therefore, the value of angle C is equals to 130 divided by 2, that is equals to 65 degrees. So our final answer is 65 degrees. Right, so again, that's the entire concept of inscribed angles together with this with its intercepted arc. Right, so thank you so much again, and God bless.